Hi, this is Sowmiya. Now we discuss about the topic transistor. Before getting to the topic, still now you wanna subscribe this channel, kindly subscribe this channel, then only you will see the continuous video when I upload on it. So now we get into the current topic, transistor. The transistor is a semiconductor device which transfers a weak signal from low resistance circuit to high resistance circuit. The word trans means transfer property and istor means resistance property offered to the junction. In other words, it's a switching device which regulates and amplifies the electrical signal like as voltage or current. The next one is transistor. Consists of two PN diode connected back to back. It has three terminals, namely emitter, base and collector. The base is the middle section which is made up of thin layers. The emitter, the right part of the diode is called emitter diode. The left part of diode is called as a collector base diode. These names are given as per the common terminal of the transistor. The emitter based junction of the transistor is connected to forward bias and collector base junction is connected in a reverse bias which offers a high resistance. Transistor symbols. There are two types of transistors, namely PNP and NPN transistor. The transistor which has two blocks of N-type semiconductor material and one block of P-type semiconductor material is known as NPN transistor. At the same time, similarly as two P-type materials are there and one N-type material is like as a PNP transistor. The symbol of transistor is like as here. The difference between two transistors is like as a direction of the current. The N means a negative charge carrier and P means a positive charge carrier. It's like as N type and P type. In NPN transistor, P is base is connected to the positive charge carrier. So here, base to emitter, current flows on the direction between base to emitter, and here current flows on emitter to base. That is a PNP transistor. Next, we look out transistor terminals. Transistor terminals like as emitter, base and collector. So let's see about the definitions of emitter, base and collector. The first one is emitter. Emitter, it is like as a forward bias and at the same time it produces a low resistance. It has a low resistance and it is connected in a forward bias direction, and collector is like as a reverse bias direction. It has a higher resistance. Okay, let's see that. First one is emitter. The section that supplies the large section of majority charge carrier is called emitter. The emitter is always connected in a forward bias with respect to the base and it supplies the majority charge carriers to the base. The emitter base junction injects a large amount of majority charge carrier into the base because it is heavily doped and moderate in size. The next one is collector. Next one is the collector. The section which collects the major portion of the majority charge carrier supplied by the emitter is called a collector. The majority charge carrier supplied by the emitter is called as collector. The collector base junction is always in reverse bias. Its main function is to remove the majority charges from its junction with the base. The collector section of the transistor is moderately doped. Emitter is heavily doped and collector is moderately doped but larger in size. Emitter is moderate in size so that it can collect most of the charge carrier supplied by the emitter. The next one is base. The last one is the base. The base is in middle section. The middle section of the transistor is known as the base. The base forms two circuits. The input circuit with the emitter and the output circuit with the collector. The The first one is emitter like us, and the emitter is input circuit and output circuit is a collector. The emitter base circuit is in a forward direction, offered the low resistance to the circuit. The collector base junction is in reverse bias and offers the higher resistance to the circuit. The base of the transistor is lightly doped and very thin, due to which it offers the majority charge carrier to the base. Like for the first one is emitter. Emitter is a reverse bias and it produces a low resistance. Collector is a reverse bias. It offers higher resistance. Emitter is moderate in size. Collector is heavily in size. It is lightly doped. That is, emitter is heavily doped in a resistor. Collector is moderately doped in a resistor. Base is lightly doped in a resistor. Working of resistor. Usually silicon is used for making the transistor because of their high voltage rating, greater current and less temperature sensitivity. The emitter base section kept in forward bias constitutes the base current which flows through the base region. The magnitude of the base current is very small. The base current causes the electrons to move into the collector region or create a hole in the base region. This is an emitter current, this is a collector current. This is a reverse bias, forward bias, base current. Here hole is created, so electrons are moved to the collector. The base of the transistor is very thin and lightly doped. So base is lightly doped. Emitter is heavily doped and collector is moderately doped in a transistor. Lightly doped base is lightly doped because of which it has less number of electrons as compared to the emitter. The few electrons of the emitter are combined with the whole of the base region, and remaining electrons are moved towards the collector region and constitute the collector current. Because base holes are created and electrons, holes are created in a base region. Holes are created in a base region, so electrons are moved from emitter to collector region. That is here. Thus, we can say the large collector current is obtained by varying the base region. Transistor operating conditions like four regions such as an active region, saturation region, cutoff region, and inverter region. Like as forward reverse bias direction, and forward direction, reverse direction, and reverse forward direction. Like as emitter junction, based on emitter junction and collector junction. The forward and reverse bias. The first one is a forward and reverse bias direction. Emitter is in a forward direction and a collector is in a reverse direction. That is an active region. The next one is forward. Both are in a forward region. That is a saturated region. Both are in a forward direction. The operation is a saturation region. Both are in a reverse direction. The operation is cutoff region. The emitter is in a reverse direction and collector is in a forward direction, forward bias. It is an inverted. The operation is like as inverted operation. It is explained here. The first one is an FR region. The transistor which operates in this region is used for amplification. In FF region, the transistor is act as a closed switch. The first one is used in active region is used for amplification. Saturation region is used for as closed switch. Both are in reverse bias direction. It also acts as a closed switch. A reverse bias direction. As the collector is lightly doped as compared to the emitter junction, it does not supply the majority charge carrier to the base. Hence, poor transistor action is achieved. Like us in FR direction, active region like us act as an amplification, saturation region act as a closed path, closed switch, cutoff region also act like as a closed switch, and inverter region does not supply the majority carriers to the base. That's it. Next we discuss about the types of transistors. The types of transistors are NPN transistor, PNP transistor, BJT, that is a bipolar junction transistor, FET, field effect transistor. The last one is a MOSFET, that is a metal oxide semiconductor, field effect transistor. Next we discuss about this topic. To never miss a video, subscribe my YouTube channel Sowmiya Vasuki, and see you in another video. Signing out Sowmiya, and at the same time, don't forget to press the notification bell. If it is useful, like this video, which is helpful for share them. Bye. Thanks for watching.